So, we got a new question with write down the 5 steps necessary to formulate a correct redox reaction in aqueous solution. So, before we do this, we have to remember a thing called oxidation state or number. And I'm gonna write the common ones. For example, for oxygen, it's usually -2. For hydrogen, it's usually +1. And there are other examples, but right now we're only needing these two. And the step 1 would be assigning the oxidation state or number. So we have magnesium MnO4 minus, which is we're gonna separate these two, magnesium and carbon dioxide. We're gonna separate those. So we're gonna write MnO4 minus and Mn2 plus. On the other side, we're gonna write C2O4 2 minus to CO2. Now, MnO4 minus, let's take the oxidation number of, or oxidation state of magnesium as X. And oxygen, we have 4 oxygens, so 4 times oxygen, it was written that it was -2, 4 times -2 equals, there's a minus sign, that is what we're gonna write the whole thing is equal to. So from this we could calculate that X is +7. Now this +7 means magnesium has lost 7 electrons, or at least that's what I keep in my mind, that magnesium on the reactant side has lost 7 electrons. Now here magnesium has +2. So when it lost 7, at first it lost 7 electrons, then it only has lost 2 electrons. So that means it gained 4 electrons after being the products. So if it gained 4 electrons, that means it's gonna be the reduction half reaction. That's also the step 2. But yeah, if the compound or atom gained electrons, then it's gonna be reduction half reaction. Let's look at the carbon. It's 2x because we have 2 carbon plus 4 times -2. Here it's 2 minus 2, yeah, which is gonna be equated as -2. And after equating, the carbon would be +3, and here it's x plus 2 times -2. There's no number up here, so it's 0. X equals +4. So from losing 3 electrons, it lost 4 electrons. That means lost 1 electron. Losing electron means oxidation. At least for now, let's say losing electrons is oxidation half reaction. That would be step 4. Step 2, assign the half reactions, oxidation and reduction half reaction. Now let's move to step 3. Balance the atoms other than H and O. Just balance the rest, like magnesium, carbon. So what do we got here? MnO4. Right side there's no oxygen, but we don't have to balance oxygen, so we could just write it as it is. MnO4 minus gives Mn2 plus. In the case of carbon, the right side has only one carbon, the left side has two carbons. Therefore, C2O4 2 minus gives 2 times CO2. Now the carbon numbers are balanced. Step 4. Step 4 would be balance the H and O using H plus or OH minus. H plus is for acidic, and it's an acidic condition from what we've seen, and OH minus for basic. These are only used in the case of H and H2O. H2O is used for oxygen. So now what do we got here? There's no oxygen on the right sides, therefore MnO4 minus gives Mn2 plus. We need 4 oxygen, therefore we're going to give it 4 water molecules. This is the part where aqueous solution or condition comes in. That's where we could give in H2O and OH minus or H plus. So the right side has 4 oxygen but 8 hydrogens. So we're gonna balance the hydrogen using 8H plus. So there we go. And that now is balanced. But in the case of C2O4 2 minus and carbon dioxide, it's just already balanced. There's no H plus or O required. Now it's the last step and the most important step. We gotta balance the charges. The charges what is the charges we're talking about? These are the charges, or the electrons we lost. I'll talk about that. Balance the charges and combine the half reactions. Balance the charges and combine the half reactions. That's the last step and the most important step. So from what we've seen, magnesium from reactant to product, it lost 5 electrons. 5 electrons. So it gained 5 electrons, again. So if it gained, this magnesium has 5 electrons more compared to the reactant magnesium. So we're gonna add, to balance that, we're gonna add this 5 electrons to the reactant side. That means MnO4 minus plus 8H plus 5E minus. That's the electrons plus Mn2 plus H2O. Yep, that's how balancing the charges looks like. Now, for the oxidation half reaction, the carbon on the left had 1 extra electron compared to the carbon on the right. So to balance that, we're gonna add 1 electron to the carbon on the right, the product side. So C2O4 2 minus. Oh, this 1 electron lost 1 electron. That's for single carbon molecule. We got 2 carbon molecules left and right. We got 2 carbon molecules, therefore 1 electron for each carbon molecule. That means 2 electrons, which is going to look like 2CO2 plus 2E minus. Now the charges are balanced, but before we combine these two, we gotta balance these charges. So what do we have to do in a way that we could cancel these charges? Multiply the whole reaction. It's like the LCM type sheet. We just gotta 5 times 2 is 10, so 5 times 2, the whole reaction times 2, and this, the whole reaction times 5. So 5 times 2, 10 electrons, 2 times 5, 10 electrons. That they're going to cancel each other. So 2MnO4 minus plus 16H plus 10E minus gives 2Mn2 plus 8H2O and 5C2O4 2 minus gives 10CO2 plus 10E minus. Look at that. We got 10 electrons on both sides. Just add the reaction, combine 2Mn. The reactant side should be on the reactant side, like the C2O4 and MnO, these things, they should be on one side. These two should be on the other side. So MnO4 minus plus 5C2O4 2 minus plus 16H plus 10E minus gives 2Mn2 plus 10CO2 plus 10E minus. Those are cancelled. And if this 5 was 6 or something, we could have divided the whole reaction by 2, but this 5 is what makes it not work. But still, wait, I forgot one thing. It was 8H2O. Yep. And this is the steps to balance a redox reaction, and this one is an acidic condition. My spelling, don't mind the spelling. Okay. So step 1 would be assigning the oxidation state number. And after that, when we assign the oxidation state number, we could see that which atom lost the electron and which one of those gained the electron. And the one who lost the electron would be having the oxidation half reaction, and one who gained would be the reduction half reaction. Then we balance the atoms without balancing the hydrogen and oxygen. This one is a simple example. That's why the oxidation half reaction did not even add anything. Step 4, balance the hydrogen and oxygen. Yeah, we just balance it. Step 5, balance the charges. That would be an important step, because this part looks like we could just add these two, but no, we should balance the charges. Only after that we should add the equations or combine the half reactions. Well, that's it.